When working with GLBP, Gateway Load Balancing Protocol, you will have your AVGs and you will have your AVFs. And we will also be dealing with different states, just like we saw with HSRP. Examine these: disabled, initial, listen, speak, standby, active. They're all the same as HSRP. So let's examine these different states from the perspective of an AVG and an AVF. Let's start off with the AVG. So what is the AVG, the Active Virtual Gateway? This is the device that will be responsible for, number one, handing out the different virtual MAC addresses to the active virtual forwarder, and then, or forwarders, and then after that, when an ARP request comes from a client, it will hand out the appropriate MAC addresses to the clients, so that way there they can get to the correct AVF as deemed by the Active Virtual Gateway. So for the Active Virtual Gateway, the interface can be in the disabled state for that particular group. And it's in the disabled state if it's configured for GLBP, but the interface is down. Because if the interface is down, it can't truly participate in the process, so it's disabled. The initial state is when it's first woken up. Let's say as an administrator, you plug in a cable to that interface, or you no-shut that particular interface. Then it's the initial state. We're waking up, we're getting out of bed, we're stretching our arms, and then we move to the listen state. Now, in the listen state for the AVG process, what are we listening for? Well, we're listening for hello packets. We want to know if there is currently an AVG out there. So let's say there is an AVG out there. If there is, we examine that hello packet. Look at the priority. Is the priority greater than or less than ours? Let's say it's greater than. All right, it stays as the AVG. Let's say the priority is less than ours. Do we have preemption enabled? If preemption's enabled, then we will take over that AVG role and we'll continue on through these different states to become the AVG. Let's say there's no hello packet at all. Well, then we want to become an AVG. So we'll go through the rest of the process. So let's move on here to the speak state. So we go to the speak state if there is any indication that we could become the standby AVG or the active AVG. So we're in the speak state right now, sending hello packets ourselves with our priority. And we are going through the election process now of trying to find out if we can become an AVG or a standby AVG. So let's say there is already an AVG out there, or an active AVG. If we are the next best, we go standby, waiting for that active AVG to fail so we can take over its role. Let's say there is no active AVG out there. Well, then we are the best, because there's no other device out there that's challenging us based on priority. So we become the active AVG at that particular point in time. There can only be one AVG within a GLBP group, but we can have multiple AVFs, active virtual forwarders, up to 4 within a group. We have the disabled state as well, meaning, well, we're configured for GLBP. We should be doing something, but the interface is down, so we can't communicate. Initial, waking up, getting out of bed, stretching the arms. Then we move to the listening state. What are we listening for? We're listening for the AVG to tell us what MAC address we are responsible for. That's what's happening during the listening state. Let's say there are 2 AVFs within the group. Well then, at this point in time, a single device should be listening for a MAC address from the AVG. The AVG tells it to use this particular MAC address, and therefore it goes active on that MAC address. However, the AVF also learns about the other MACs for the group. So it learns about the other MAC address that will be utilized. Because remember, we said we had 2 forwarders in this case. But it stays in the listening state for that one. Because there is another device that will be active. So the other device will be active for that MAC address. So let's make this a little bigger. Let's say we had 4 active virtual forwarders. That means each device would be active on one of those MAC addresses and listening for the other 3. Now, why are they listening for the other 3, and why do they even learn about them? Because if there's a failure, since we already know about the MAC address and we're listening, now the AVG has the ability to tell us to become the active forwarder for that other MAC address as well. So all of a sudden, if one of those AVFs fail, one of the other AVFs that are left in the group can now be responsible for 2 of the MAC addresses. Its primary one plus the secondary one that it was listening on originally. But now that the other device failed, it goes active on that. So this is how we can fail over and still provide that high availability and have the redundancy for the default gateways.